Hello and welcome to Unit 4, Lesson 5 on completing the square. In this section, we are learning how to solve quadratic equations by the fourth method of completing the square. So let's take a moment to review the methods we've already learned. We have learned how to solve equations by graphing. We've learned how to solve quadratic equations by square roots. We've learned to solve quadratic equations by factoring. Each one of those had a very specific case and specific use. So now we move to through the sections that allow us to solve any type of quadratic equation. So in the blue section down here, you can see the steps for completing the square. Completing the square can be a little more tedious than any of our other methods, so we will take it step by step and look at all of those steps through some examples together. But before we do that, there is one special pattern that we need to remember and learn how to use completing the square. So while completing the square can be used for every quadratic equation, we typically use it when we have a quadratic equation where a is equal to 1, where b is an even number, and where we cannot factor it easily. So we remember our standard form of a quadratic is ax squared plus bx plus c is equal to 0. So when a is equal to 1 and b is even, so 2, 4, 6, 8, and also those negatives as well. So we can use completing the square for any quadratic function, but the numbers are a little more messy when a does not equal 1 or when b is odd. So before we get to the steps of completing the square, we have to practice one of the patterns we learned earlier, and that was how to factor perfect trinomial squares. So we had this example where we had something that had a perfect square at in the first term, 2 times a times b in the middle, and b squared in the last term. And this we could factor as a plus b, or a plus b squared. We could also do that if it was a negative sign and our signs would change. In this section, we're going to use this process of factoring perfect trinomial squares, so we need to know how to create them. So we're going to create situations where we can make this factoring possible. So let's take a look at these examples. What is the value of c such that the following expressions are perfect trinomial squares? So we need to look at our pattern, and we have a positive pattern and a negative pattern, and in this case we should have negative. So it needs to follow the form a squared minus 2 times a times b plus b squared. So in order to find what c equals, we need to know what b equals. So I know here that negative 20x, or this middle term, equals the middle part of our pattern, or negative 2ab. And I know that a is equal to 1 because there is no number written there, so we can assume it's 1. So we can plug that in. So we get negative 20x equals negative 2 times 1 times b. And we know that this term should also have an x in it, so we have to divide both sides by negative 2. So we know that b must equal negative 10. So if b equals negative 10, b squared equals 100. So my perfect trinomial square here is x squared minus 20x plus 100. And we can factor this as x minus 10 squared. So in completing the square, our first step is to understand our pattern, to find this c term, and to be able to factor. So let's try another one. The shortcut here is that in order to find c, c has to equal half of our b term squared. So in this case, our b is equal to negative 5. So we can take half of b and square it. Now remember I said this becomes a little more complicated when it's odd because we end up with some fractions. So I can't evenly divide negative 5 over 2. So I just have to square both the numerator and the denominator, and I get 25 over 4. So this is k squared minus 5k plus 25 over 4. And if I were factoring this, I know that it's my square root of my first term, my first sign, and the square root of my last term. And it's all squared. So that looks a little crazy, but hopefully that's jarring some memories. As we go through this, we have to find that c term first. So let's put it all together. So right here we have all of the steps to completing the square. And we're going to only use completing the square when b is even and a is equal to 1. Otherwise, we'll learn our next method in the next section that solves quadratic equations for any type of quadratic equation. So when we are learning to complete the square, we have to get the x squared and the x on one side of the equal sign and the constant term alone. So that means my variables all need to be on one side and my constant term needs to be alone. And in this case, it is. So we already have our variables equals our constant. So we're going to rewrite this like this. And I'm going to leave some spaces here because our next step is to do just what we did up in that first example. We're going to find half of b and square it, and we're going to add that to both sides. So c, my c term here, equals half of b. So my b term is negative 4. I'm going to take half of that, and I'm going to square it. So negative 4 divided by 2 is 2, so 2 squared is 4. And I'm going to add that to both sides. So that's this step right here. I'm going to take half of b and I'm going to square it, and I'm going to add that to both sides. And now that I have created this perfect trinomial square over here, I can factor it. And so we remember from above that since we manufactured this to be a perfect trinomial square, we can factor this as r minus, and then it's the square root of this term, 2 squared, equals 34. So that is our third step. We're going to factor using that perfect trinomial square. And now we have to solve. And we can solve by taking the square root of both sides. And we remember from our first method, if I take the square root, I have to do plus or minus the square root over here. So I end up with the square root cancels the square. So I get r minus 2 equals plus or minus radical 34. And I still need to get this r alone. So the square root portion is that step. And then our last step is to solve for the variable. So I need to get r alone. So I'm going to add 2 to both sides. And this sometimes looks a little tricky. So r equals 2 plus or minus radical 34. And it might ask us to put that in decimal form. So we can do that by doing 2 plus 34 square root equals. So our answer is r equals 7.8. And then we're going to take that back and we're going to do 2 minus 34 square root equals, and that's our second answer, or negative 3.8. So remember, every quadratic has 1, 2, or 0 solutions. So we want to make sure that we capture both of those solutions. Take a moment to review that process, pause the video, and come back when you're ready for the next example. Okay, our next example is m squared plus 12m plus 19 equals 0. So we are going to start by getting the variables alone on the left. So I'm going to do that by subtracting 19 from both sides. So I get m squared plus 12m equals negative 19. And I know that I'm going to have to add in some things here. So I'm going to leave my room there. My next step is to find half of b and square it. So b is 12, so I get 12 divided by 2 squared. So I get 6 squared is 36, so I'm going to add 36 to both sides. And I am going to factor using my perfect trinomial squares. So I get m plus 6 squared equals 17. And then I'm going to move to the next step, and I'm going to take the square root of both sides. And when I take the square root, I have to add in that plus and minus. My square root cancels the square, so I get m plus 6 equals plus or minus radical 17. And then I'm going to do my last step and solve for the variable. So I'm going to subtract 6 from both sides. So I get m equals negative 6 plus or minus radical 17. And I'm going to pull up my calculator. And I can do 6 negative plus 17 radical equals negative 1.88 rounded, negative 1.88, or, and then I'm going to go ahead and do negative 6 minus 17 radical, and that's going to give me negative 10.12. Okay, I'm going to take a minute and review that. When you're ready to move on to the next one, please do so. Our next example is a little different, and this step is not in here. So I'm going to put it up here. If a does not equal 1, like in this case, we have to divide every term by a in order to get it equal to negative or to positive 1. So we're going to divide everything by 2 to go get v squared minus 5v minus 10 equals 8. I'm going to pause the video, complete the problem. Here is the problem all worked out. You can see that when b is not even, it gets a little messy. Be sure to review all of the problems if you